same system. We're going to write the system as a matrix equation. And the way that system is written is this. Okay, the 2, 3, 4, negative 5 go into this matrix here. And the xy go into a matrix like this, column matrix. And the negative 2, 18 are here. Okay, now let me explain how this works. And I'm kind of covering up what's coming ahead so that you can figure this out on your own to an extent. Okay, now, the rule for multiplying matrices starts out, if you multiply the first row of the matrix by the first column, you get the first number. Now, what's that mean? It means if you multiply the first row, well, there's the first row, 2, 3. By the column, which is xy, you get the first number here. So first row gives you first number. First row times first column gives you the first number. So 2, 3 times xy equals negative 2. Now, why don't you interpret what it means for the second row times the second column to equal the second number? You should write that out, and of course I'm going to write it out right now. But you should have done this already by yourself without any looking ahead. Okay, so the second row is what? 4, negative 5. That's the second row. And the column is xy. And that's going to be the second number. Now, the only thing that makes sense as a second number over here on the right side is the 18. Okay? So this matrix equation is equivalent to this and this. It's just a shorthand way of writing both this and this in one simple equation. Now, we haven't talked about what it means to multiply a row by a column, so we need to do that. Well, and my handwriting isn't that great up here. I think I got in a little bit of a hurry, but hopefully we can read it. Row times column equals first number times first number plus second number times second number. Now don't look here, look down here. What does it make sense to do here? If we want to multiply the row by the column, first number times first number, second number times second number. Well, okay, let's look over here for a minute now. Let's do this example. Okay, here's an example. So first number times first number plus second number times second number. Don't look at the answer. Work it out yourself, then compare. What does it make sense to do? Okay, well, you should have done that. First number times first number, second number times second number. First number in the row is 1, first number in the column is 5. Second number in the row is 4, second number in the column is 3. So we multiply 1 by 5, first number times first number, second number times second number, 4 times 3, and we add them, and we get 17. Now you should work this out. Don't look ahead. Just work this one out. Everybody, I think, in class was able to follow the pattern and figure out what to do here. I think everybody got the right answer. So you should pause and do it, and then check. And when you do, and you should have done that by now, you get these three numbers, and they add up to 64. So now, what do we mean by 2, 3 times xy? Let's look over here. 2, 3 times xy. What would you do? Okay, you shouldn't have done that. You're going to multiply the first number by the first number. Now, the first number here is x. It's no longer a number, but that's not a problem. Second number times second number, 3 times y. So I've written it out over here. 2, 3 times xy. 2 times x here. 3 times y here. And then we did 4 minus 5 times xy, and that gives us 4 times x and minus 5 times y. And that's what we would get here. So what does our matrix tell us? If we go back to the matrix, the first row times the column times the first column gives us the first number. That's our first equation. Second row times the column equals the second number. That's our second equation. The left-hand side is the left-hand side of the equation, and it's going to be equal to 18. So this equation gives us 2x plus 3y equals negative 2. This one gives us 4x minus 5y excuse me, equals 18. Okay, now, you don't know what good this is. It's plenty of good, and we'll talk about that very shortly. But first thing you need to do is see how to represent a system of equations as a matrix equation. So we write this system as this equation, and then we interpret what all that means.